Hi everyone, welcome to my presentation of Getting to Know Database 21C. My sincere thanks to APAC, OUC, and Francisco for accepting my submission and giving me the opportunity to talk to all of you. This is me. My name is Aman Sharma. I have been working with Oracle database for about 15 plus years. I'm an Oracle ace. I specialize in Oracle database, and I'm the co-author of two books in backup and recovery, one with my dear friend Francisco and another with my dear friend Cameron. I tweet here. Do follow me in case you're not already. The profile is locked, but of course, you can just send the invite and I will be gladly accepting it. Okay, so before we talk anything else, or before we talk about anything else, let's talk about the Oracle ACE program. Oracle ACE program is basically probably one of the best programs in terms of communities, and Oracle ACE program is basically an endeavor to find out the people who are technically proficient, people who are experts in their particular domains, and they are most willing to help others as well. I'm sorry. Oracle ACE program has 3 tiers: Oracle ACE Director, Oracle ACE, and ACE Associate. And Oracle ACE program is basically a community nomination program. So if you know someone who is very good in terms of their domain, in terms of different technologies in Oracle database and such, or any other technologies of Oracle, do bring that person forward. Nominate that person. If you are such person who enjoys helping others, who enjoys helping community, please nominate yourself. And a huge thanks to Oracle ACE program for building this community of experts and great people from all around the world. Very humbled and very honored to be a part of Oracle ACE program myself. Okay, so let's talk about agenda, which is very simple. We will talk about some things in database 21C. So 21C is basically going to be a converged database for all data-driven application use cases. Converged database is basically going to support all data types and workloads. They can handle any development paradigm, including microservices, events, REST, and SaaS, to name just a few. By integrating data types and workloads as features within a converged database, you can support mixed workloads and data types using a common language like SQL and a standard set of APIs. You don't need to manage and maintain multiple systems or worry about having to provide unified security across them. You also get synergy across data types and workloads, for example, by having support for machine learning algorithms and spatial data in the same database. You can efficiently run predictive analysis on spatial data. Data-driven app development becomes dramatically more straightforward and faster. And obviously, it helps you to basically do the things in a more easier way, or you can say less complicated way, which of course is going to reduce the cost of maintenance and so. And obviously that is going to make the things more reliable as well. And definitely Oracle database is the best enterprise class database that we have in the market. In terms of the database 21C, one of the biggest things which has been enhanced, or you can say included, is actually the database AutoUpgrade feature. So starting from database 21C, AutoUpgrade automates the steps which are necessary to upgrade a database in an Oracle database environment. And this particular feature basically came up from 19C, which was actually to introduce the upgrade of data guard configurations and rack. The steps which are basically going to be used in terms of auto upgrade, they basically include disabling and re-enabling the broker if it is going to be present, and deferring any kind of log file transport while the upgrade is actually taking place. And automation of these data guard operations in the context of database upgrade eliminates the need for manual or scripted steps that you otherwise would have to perform by yourself, and which obviously makes the the whole upgrade scenario actually much more easier. Also from 21C, the auto upgrade is going to automate all the steps needed basically to upgrade an Oracle replication cluster database. The steps which are going to be there, they previously had to be performed manually or scripted, and the steps that auto upgrade automates, they include the srvctl commands to stop, restart the instance on multiple nodes, handling of cluster databases or cluster database parameter, updating multiple parameter files, restarting services wherever they're going to be appropriated, and so. And obviously this is going to really actually eliminate the possibility of manual errors, and obviously going to decrease the work which is going to be needed by the DBAs to perform such steps. Now from 21C, the steps which are going to be required to upgrade a database in data guard configuration is going to be there, and these steps obviously are basically going to be necessary to basically include the upgrade in terms of data guard environments. And this upgrade feature is going to include this disabling and re-enabling of the data guard broker. Now obviously once this is going to be there, it means that the configurations or the steps required to enable or upgrade the data guard configuration is actually going to be faster and better. And the same is actually going to be there for the rack environment. So as I mentioned that the particular changes or the handlings of parameters or the cluster database parameter or managing services of the rack environments, they are all basically going to be handled using this auto upgrade part for the system. Also, in terms of the 21C, the auto upgrade is going to automate the steps which are going to be required to upgrade and convert a particular non-CDB to a PDB, which is definitely going to simplify the upgrade process if it is going to be required. 21C requires multi-tenant architecture in terms of functionality, and with this release, you can use auto upgrade for non-CDB to PDB to upgrade from database release 12C, 12.2 and subsequent releases after that. And using this automation feature of auto upgrade is basically going to reduce the effort required by the DBAs for upgrade, and it is also going to mitigate the risks associated with typographical errors, which normally are very common in terms of doing the same task in terms of a manual process. And this particular process of doing this auto upgrade is basically going to be using the unplug, plug, and then upgrade functionality. So the idea basically is that it is going to automate the process of the particular PDB to be unplugged from the CDB. Then it is going to be plugged into a higher version CDB, and it is going to be upgraded then finally to a new target version. And PDBs, they can be upgraded using this unplug and plug functionality, which is basically going to be taken care. We can also have the entire database actually to have the benefit of this particular auto upgrade. So auto upgrade is going to enable you to upgrade one or many Oracle database instances at the command line using a single command and a single configuration file. Auto upgrade is going to run the pre-upgrade tasks will perform the automated fix-up wherever they are going to be needed. It's going to run the database upgrade, and it's going to finish by completing also the post-upgrade tasks. AutoUpgrade is going to include the automatic retries and fallback, the options to schedule the upgrade for some time in the future, and the ability to set, change, or remove the parameters whenever they are going to be required or they're going to be actually desired. And obviously using AutoUpgrade can save a DBA or a shop time and money by enabling to upgrade hundreds of databases with just one command, and you do not really need to have high maintenance upgrade solutions in terms of your system. So one of the major things that 21C is actually going to have is basically going to be the particular part of having the system basically getting the benefit of AutoUpgrade. The next set of few features that we are going to see are basically going to be in terms of performance, or the enhancements which are done in terms of the areas which are basically going to be about performance, and some other options which are going to be there as well for the same. So in the very first particular part, we will see some of the enhancements which have been done in terms of ACFS. So here's a list basically which I've just put up in terms of the enhancements which are there in ACFS. So let's see each one of them one by one. So ACFS is basically going to have now the automatic shrinking, or ACFS automatic shrinking is basically going to automatically shrink on ACFS based file systems on a policy, provided there is going to be, or providing there is going to be enough free storage which is going to be available in the volume. Now this automatic shrinking option of -s of the ACFS util size command is going to shrink a file system by 25% if it is going to be 50% full, and if it was at least 80% full since the last expansion or since the last mkfs command actually was run, if it was a new file system. ACFS is going to check once an hour to determine whether the file system meets the automatic shrink criteria. When the criteria has been detected, the automatic shrinking process begins within an hour if automatic shrinking has not already occurred that day. At most, one automatic shrink action is going to occur daily, and the operation is run on the file system in the background. If automatic shrinking is enabled, then ACFS util info fs is going to display AutoShrink enabled in the output, and ACFS automatic shrinking is going to be enabled on the Linux environment. The next advantage, or the next enhancement which is there in the 21C, is the basically support of mixed sector size. So mixed sector support is going to enable the Linux primary and accelerator volumes of an Oracle ACFS file system to use a mix of different logical sector sizes onto one environment. For example, 512 bytes and 4096 bytes together actually. To use this, obviously the compatible ADVM should be at least 20.1 or higher, which is actually going to be needed. Another thing which is going to be there in terms of the ACFS is the file-based snapshots, which provide the ability to create snapshots of individual Oracle ACFS files in a much better way in terms of the file system, or in terms of the Linux file system. And using this, obviously we can actually have the benefit that we can actually create the kind of snapshots if we need basically onto particular storage for our files. I've just put up a command for the sake of reference. So this particular capability is not going to consume any kind of storage unless it is not going to be modified, and the storage is basically going to be using the functionality of COW or copy on write. So it's going to be a sparse file which is going to be created, and that file will not use any space unless there is no modification which is actually going to be done onto the particular file. Also, in terms of the ACFS, the replication failover is going to provide in 21C the unplanned failover, where the standby location assumes the role of the primary in case of a failure. The ACFS util REPL failure command reverses the role of a replication standby location, so it becomes a replication primary location or optionally terminates the replication relationship. The failover command ensures that the standby location contains an exact copy of the results of the last successful replication transfer, and if required, the command is going to restore the location back to its state as of that transfer. And this is going to be dependent on different scenarios in which it is actually going to be used. For example, both the standby location and the primary location, if they're operating normally, in that scenario, the command is going to reverse the replication relationship. If there is no data loss, in that case, it is actually going to be working fine. Now, the failover probably can fail in this case if the replication is going to be paused, and to allow this case to succeed, you have to run the ACFS util REPL resume command. Another scenario can be that the primary location is not currently available, but you want to wait until it's back online. In this scenario, the command verifies the status of replication primary. If the primary is not accessible and the timeout period has expired, if you have specified that, then the command is going to restore the standby location to its state as of the last successful replication transfer and converts it into a replication primary. Some data loss probably is possible. For example, if there was a transfer which was going on when the primary location becomes unavailable. When the original primary becomes again available, the system is going to be aware that failover command has been run, and it's going to convert itself into a replication standby location. The next part is going to be about some of the things in terms of the data guard enhancements. So there are quite a few enhancements which has been there in terms of data guard, like the result cache. The result cache in an active data guard standby database is utilized to cache results of queries that were run on the physical standby database. In the case of role transition to primary, the standby database result cache will now be preserved, ensuring the performance for offloaded reporting and other queries will continue without really compromising the performance benefit of the standby result cache. And use of this is obviously going to improve the query performance for recurring queries and is going to minimize the performance impact on the primary and standby databases. And by maintaining this result cache on the standby, the performance of any query that we're running on the standby will be maintained, ensuring previously offloaded reporting and other read-only operations are not going to be impacted by this transition also. The FastSync instance can be fully utilized in the max performance mode in terms of both normal configuration and in terms of the fast start failover is going to be enabled. And this is basically going to additionally allow much better RTO and RPOs to be met when FastSync is going to be used in terms of your active data guard configuration. There are fast start failover callouts which are going to be now available to use. Callout scripts are now available to use with fast start failover. These scripts can contain user-defined commands that are run before and after a FSFO operation, with the additional flexibility provided by the scripts administrators can automate manual actions, which must be performed before FSFO events are initiated as well, or once an FSFO event is actually going to be completed. And this provides a more consistent and adaptable configuration, reducing the chances for human errors to be there in terms of these events. You have configuration validation, which is now going to be there, and we will see an example of that or command for that. We have PDB recovery isolation, which is actually there. So PDB recovery isolation ensures a single PDB recovery while managed standby recovery is recovering other PDBs and prevents administrative PDB operations on the primary database from interfering with the recovery of other PDBs on the standby database. And there is also the standardization of the DataGuard broker directory structure. So now the broker is going to use a standardized structure to store the client-side files, and using a standardized directory structure is going to help you to keep your DataGuard environment much better organized and consistent. And management is further simplified by using the configuration aliases to identify a specific DataGuard configuration. So the FastSync instance creation, which is going to be there, so that is going to allow the users to create and add a FastSync instance to a DataGuard broker configuration using the create FastSync command, which is obviously going to be enabling the zero data loss over longer distances using this FastSync standby instances. And to even to use this particular setup or to make this kind of maintenance for these instances available, the broker also can be a part of this configuration. Like we discussed, that we have the callout scripts actually available. So these callout scripts are going to be available now to enhance the functionality. So these scripts can be automatically performing tasks before fast start failover operation. The name of the callout configurations file is going to be fsfo callout.ora, and you cannot use a different name for this file, and it is going to be stored under the dgadmin /config configuration simple name and then callout directory. If you have not defined this dgadmin variable, or the directory specified by this variable will not exist, or the directory does not really have permissions, then this callout is actually going to fail. The script is going to be named as fsfo callout.ora, and these scripts must be in the same directory as the callout configuration file. So you can create two callout configuration scripts, a pre-callout and a post-callout. And before a fast start failover operation, the observer is going to check if a fast start failover configuration file is actually going to exist. If it is going to be existing and it contains a pre-callout script location, this script is run before the fast start failover is initiated. And after the fast start failover is going to succeed, a post callout script is specified in the fast start failover configuration, and the script is going to run. And there is going to be another validate fast start failover command, which is going to parse the callout configuration script and check for errors or misconfigurations. There's going to be a standardized directory, so the client-side broker files will include the observer configuration file observer.ora, log file, fast start failover logs, fsfo.dat, and the fast start failover callout files. So starting from the 21C, you are encouraged actually to use dgadmin environment variable to specify the default location for these files. And the files are stored in subdirectories which are going to be under the dgadmin variable. You must create the directories which are going to be specified in terms of dgadmin, and make sure that the right permissions are actually present for these particular folders. There are different folders which are going to be required, like admin, which is basically for configuration file, configuration name, which is going to store the files, which are going to be for the observer and callout. And you do need permission. So on Linux and Unix platforms, the directory which is going to be specified by the dgadmin must have read, write, and execute permissions for the directory owner. The subdirectories that DGMGRL creates under this directory will also have the same permission. If the environment variable is not set or the specified directory does not exist, then the broker is going to store the FastStartFailoverLag file and observer configuration file in your current working directory, and it will also use the standard output basically to store any or to display any particular observer logs. Now when anytime DGMGRL is going to start, it is going to check if the default directory for the client side files actually exist. If it does not, it will actually try to basically go ahead and use the old behavior. Otherwise, it's will try actually to configure the subdirectories if it is going to be required. There are going to be some desupported features. So these are all the parameters which are basically deprecated in 19C, and now they are all desupported, like archive lag target. I'm sure all of you must have used it at least, or must have heard about it at least sometime. They are now actually desupported, so it's no longer actually basically there in terms of the system. Another very interesting command which is actually there is called now prepare database for data guard. Okay, so we do have the FastStartFailoverLimit configuration property which is there. So this is basically going to be in case there is no synchronous standby destinations available. In that case, the FastStartFailoverLagLimit property is going to establish an acceptable limit in seconds that the standby is allowed to fall behind the primary in terms of redo applied. If the limit or this particular threshold is going to be reached, then a fast start failover is not allowed, and the minimum value for this is going to be 5 seconds. And this is going to be useful when fast start failover is enabled and the configuration is operating in max performance mode. The command that we were talking about is prepare database for data guard, which is basically going to allow, or which is going to configure a database and set up to be used as a primary database in a broker configuration. It takes a couple of inputs like the database unique name, what is going to be the directory location with the help of DB recovery file dest, what is the size which is going to be there for DB recovery file dest, broken configuration file, where it is going to be. So both the locations are actually going to be there, and it is going to maintain multiple parameters, initialization parameters actually for you. Like it is going to set automatically the number of files, DB files 1024. It will set the parameters for the blocks to be checked. It will check for, it will set actually the DB flashback retention. And this command is going to enable automatically for you the archive log mode, force logging, flashback database, and it is also going to be setting the RMAN archive deletion policy to shipped all standby, right? So basically going to be handling pretty much all the tasks by itself. And in the same pattern, there is going to be another option which is basically going to be the validate fast start failover. So validate fast start failover is going to enable you to validate a fast start failover configuration, which is basically going to identify misconfigurations either while setting up or initiating the fast start failover. And this is going to validate the fast start failover configuration and will report, for example, any incorrect setup in terms of failover parameter, like failover threshold is not set properly, for example. And it is going to also mention any effect actions which possibly can be there if the fast start failover is going to be initiated, or the stability of the broker. So all of that is basically going to be the part of this option. There are going to be few automatic operations, and I believe the time is running out. So let's see how much we can actually quickly cover. In terms of automatic operations, we do have the operations of materialized views and all, but let's just talk about something which is going to be about the index optimization. There are many other things, SQL tuning and dynamic, resizing for the sequence values and so. But this is basically going to be about the data optimization policies for indexes. And that means that the ADO policies or data optimization policies, which are actually there, they can be extended basically for tables to provide the segments, housekeeping. For example, the movement, the compression, optimization, and all these things on the indexes. So 21C is basically going to have these particular ADO functionality, which we already have in the previous versions on the tables, to be actually implemented onto the indexes. And this optimization process is basically going to do the tasks which are applicable to the indexes. For example, compressing the indexes, shrinking them, or rebuilding them. And when you're going to be having this optimize clause actually used, basically the database is going to determine which action is going to be optimal for the index and implements that action as a part of the optimization process. You don't really have to specify which action actually has to be taken basically for that. Now, the first thing which you have to do as a DBA is to enable the heat map, so the tracking actually has to be activated. The statistics are going to be collected in terms of the view $heat map segment, and they're going to be flushed out by the scheduler job to the permanent view heat map stat $. And this persistent data is going to be visible through the view DBA heat map segment histograms. After this, you just need to create a policy for the index as the default behavior for it. And then you have to schedule that when the policy is actually going to be evaluated, or what should be the criteria basically for that. The policy evaluation is going to be based upon the heat map statistics, and the process MON is going to evaluate the row level policies periodically, and it is going to start the jobs to compress whichever blocks are going to be qualifying for it. DBAs can see this entire thing in terms of the DBA ILM evaluation details and DBA ILM results. And finally, the DBAs can verify whether the segment is possibly moved to another table space and is stored in the right particular policy, right table space which is defined in the particular policy, and if the index is actually compressed or not, which we can check using the compression stat $ table. The particular same thing is going to be there for the views. So materialized views, they basically are going to be the objects which allow us to have the potential to improve the query performance. And database now incorporates the workload monitoring to check that what materialized views are actually going to be basically needed. And again, based upon that, the particular views and the view logs are actually going to be created, and they are going to be maintained automatically now without really requiring a user intervention. And to also do this particular part, the system is going to constantly check the workload which is going to come onto the environment. There is going to be other two things which are going to be there. So you have object activity tracking system, which is going to track the use of different database objects, and this use is basically about everything. It includes the use of access, the DMLs, or the refresh. And this automatic tracking of how the objects are being used is going to help you to gain a better insight on how your applications are querying, manipulating the database and its objects. And it will also feed the tools which are used internally, like Access Advisor, for example, or automatic material views, basically to get better results or better updates actually for you. The sequence dynamic resize, caching resize is basically going to have the option that the sequence cache is now auto-tuned based upon the rate of consumption of sequence values, which means the cache can automatically grow and shrink over time depending on the usage, while not really going to fail behind the DDL specified cache size. By obviously doing this dynamic resize cache, the performance can be improved significantly, especially for the fast insert workloads on rack. And also this dynamic resizing of the cache can improve the performance for fast insert workloads which are going to use sequences. So obviously this is basically going to be done by reducing the number of trips to the disks, which are not really going to be needed now because the cache is actually going to be handling it. The zone maps are actually going to be created and maintained for any user table now without any user intervention. And they are basically going to be maintained for the direct loads in the environment. I think I jumped forward. So this is going to be the detail sort of like which is going to be there. So 21C is going to allow you to enable creation and maintenance of the zone maps for both partitioned and non-partitioned tables by using a new package and a procedure, which is dbms auto zone map.configure. An automatic zone map creation is turned off by default. Enabling this does not really require any DBA intervention any longer for both the creation of the zone maps and their maintenance. The zone maps can still be created manually though, but it is going to be automatic if you are going to be onto the cloud database, autonomous database environment. Some of the features like IoTs, index organized tables, external tables, temporary tables, they are not actually going to be there. So 19C, they were also there, but they were explicitly created. But in terms of 21C, they're going to be automatically created, by the system. So this is going to be the package. Of course, it's basically going to be handling everything for you. So this is the new package, which is going to allow you to set the configuration options for automatic zone map to enable or disable the feature and to control the foreground or the background modes of the feature. There are different values for it, like on, off, foreground or background. So on is basically going to on the automatic zone map, off is actually going to off it, foreground is basically going to turn it on only for the foreground creation, and background is basically for the background part. Some of the views where this information actually can be there. So from these views, the information about the particular part is actually going to be there, and some columns are actually added to DBA zone map auto actions, which is going to show you these particular automatic zone map tasks which are actually created in the system. And similarly for auto findings also, there are different columns which are actually going to be there or going to be added. Like finding reason is a column which is actually added for the reasons which are actually there in terms of any kind of zone map creation. The next thing is going to be about the secure file defragmentation. So there is a new view, $SecureFileShrink, which is going to report the result of this particular defragment operation. So this is already there in terms of the 19C, but in terms of the 21C, whenever there is going to be any kind of shrink operation invocation is going to be there, a new row is actually going to be entered into the $SecureFileShrink view, and the shrink, once it is going to be done, the row is going to remain static, and a new invocation of the shrink for the same segment is actually going to overwrite the row, which means that the view does not really actually get bigger and bigger actually a lot. In terms of ASM as well, there is going to be some of things like the ASMCA you can actually have. So it is basically going to allow you to have the flex ASM on a configuration which is previously configured on NFS. We have the enhanced double parity protection for flex and extended disk groups in the system. So you can actually use double parity protection for write once files in an Oracle ASM flex disk group. You have the file group templates, which you can actually customize and set default file group properties for automatically created file groups by basically enabling you to customize the file group properties which are going to be having or going to be used by a number of databases. Obviously, without them, if you wanted to change a property for an automatically created file group, you would have to manually change the property after the associated file are created, which obviously will possibly create unnecessary rebalance, and this is a much better option. Previously, point-in-time databases clones would only clone a pluggable database in a multi-tenant CDB to a new PDB in the same CDB. Now this restriction is no longer actually there. Now you can actually clone a PDB in a CDB to a new PDB in a different CDB. The last bit is about the Autonomous Health Framework. Autonomous Health Framework is having many things actually included. For example, the sector support, enhanced support for the Exadata. So the Cluster Health Advisor can actually detect the performance and availability issues on Exadata systems. It can actually detect performance and availability using the database and node models. The Cluster Health Advisor is also available for Solaris in case you're going to be actually running the rack on Solaris. With the Cluster Health Monitor local mode support, now you can actually have the Cluster Health Monitor to operate on a local mode and to report the operating system metrics using the OCL umon dump node command. Even if you have not really configured the Jimmer actually on the system. So in a local mode, you can actually obviously get the local data, and this local mode has limited functionality in the deployment when you have not installed the Jimmer. Earlier versions, the Cluster Health Monitor required the Jimmer to be there to get this particular reporting done, but now even without that, you can actually have this. And from 21C, the support for REST APIs are there to add a remote interface to the existing OraCheck or ExaCheck CLIs. You can manage software deployments remotely from centralized consoles and web interfaces. And by supporting the REST interfaces, the OraCheck and ExaCheck is going to integrate into the applications, and they can be much useful in terms of a cloud management environment. The trace file analyzer is going to generate, possibly now to generate a real-time health summary, which is going to show performance degradations due to false and workload issues. And trace file analyzer is going to collect multiple service request data collections into a single collection, even if it detects multiple issues or errors at the same time. And also the remote grid infrastructure management repository feature for the cluster, standalone cluster, is going to now allow you to have a centralized Jimmer, which basically does not require now to have local cluster resource to host the Jimmer. And this basically provides access to a persistent data store that significantly enhances the proactive diagnostic functionality of Cluster Health Monitor, Advisor, Autonomous Health Framework. And the remote Jimmer feature is going to save the upfront cost by freeing up the resources, local resources, onto the system. And also in terms of the autonomous framework, the support for quality of service is actually there. So quality of service is basically going to configure a default policy or policy set based upon the service it is going to discover, which is actually going to be going to be running or going to be available in the system. And it means that workload performance data is always available to you, and it can be used basically for the autonomous health framework. Also the support of grid infrastructure, you can or you must have to actually configure the grid infrastructure management repository in a separate Oracle home instead of the grid home. And this basically is going to be, this option is going to be available when you configure the Jimmer during a fresh Oracle grid infrastructure installation, or when you add a Jimmer to an existing deployment. It is mandatory to configure Jimmer in a separate Oracle home when you upgrade to Oracle grid infrastructure with an existing Jimmer deployed in it. A separate home is good because obviously you can use faster upgrades. It will have much better options to have the rollback, and the grid infrastructure installation user also have to own the same Gmer, home actually. Okay, I think just about the time. So that completes the introduction to Database 21c. Lot of things probably to look into when you go back. Thanks to Francisco and APACOUC to give the opportunity, and thank you everyone to listen to this presentation. I'll meet you on Twitter, and thank you so very much. Stay safe.